Let us have a simple introduction of linear regression, or this week we'll be having a simple linear regression na topic. Although this, you already have a prior knowledge on this when you had your data mining, but this time we will explore it in the application of Python and another, or in the Colab environment. When you say regression model, it simply discuss now, or say describe the relationship between two variables, or variables where changes in some variables may explain or possibly cause changes in other variables. So that means we have two types of variable here. The one that is that change depending on the other variables, and then the other one which is a fixed value. So explanatory variables are termed the independent variables. So explanatory because when you look at it, you would simply assess that the value is fixed. And the variable to be explained are termed the dependent variable, meaning these variables have other variables to consider before a certain value might be derived. So regression model estimates the nature of the relationship between the independent and dependent variables. So change in dependent variables that results from changes in independent variables, that is size of the relationship. So strength of the relationship, statistical significance of the relationship, that will sometimes or most of the time considered the cause of the changes of the variable. So example, so independent variable is a retail price of gasoline in Regina. Regina example is a company, while independent variable is the price of a crude oil. Why we considered retail price as a dependent variable? Because sometimes when you say retail, that would differ depending on the number of volume of a crude oil, or that depending on the price of the crude oil, such that this will be the price of a retail if you would get a certain range of a price of a crude oil, or should we say it as the volume of the crude oil that you will be buying will be dependent over the price of the gasoline retail price. Another dependent variable is employment income, wherein the independent variables are hours of work, education, occupation, gender, age, region, years of experience, and unionization status. Wherein, when you say independent variable, when you say work of hours, that fix. It is not reliant to anything. Rather, 10 hours of work is exactly 10 hours. Education is also fixed. Like if you're a graduate of a master's or of a baccalaureate degree, occupation is also fixed. Then number of years of experience is also a fixed value. That means they can stand on their own. That defines them as independent variable. While when you compute now employment, you have to consider the education, the number of years of experience, the occupation or the nature of work, the number of hours that would be spent into the work. And that's how you compute or you determine the employment income. So in other words, there are variables that you have to consider when you compute or when you determine the employment income. And what are these variables? So these are hours of work, education, occupation, etc. So price of a product and quantity produced or sold. So what makes this two variable say dependent to other independent variable? So quantity sold affected by price. Dependent variable is quantity of products sold, while the independent variable is the price. So the quantity will be very dependent of the price that you will set. So price is set to a specific amount, and the quantity will vary depending on the price. Another is price affected by quantity offered for sale. So dependent variable is price, independent variable is quantity sold. So this is the other way around as well, wherein price would determine first, or would be very dependent on the quantity to be sold. So wherein quantity is a fixed value, like there will be 10 barrels, and then the price will differ depending on the number of barrels, or say they have specific range of barrels that you will be buying for a certain price. So in other words, price is a dependent variable, while quantity sold is the independent variable. So this is a graph of a crude oil price index year 1997, and the gasoline price per cents per liter in the x-axis. So when you say bivariate and multivariate models, a bivariate or simple regression is a two variable involved model, wherein you just have your x and your y, wherein your y serve as your dependent variable and your x is your independent variable. But for the multivariate or multiple regression model, it involves now different 1 to 4, or depending on many variables to determine the value of y, wherein y is your dependent variable and your independent variable are the education, sex, experience, and age. And these are then the variable that represents each of these. Model with simultaneous relationship, that means the one that I have mentioned a while ago, wherein the price can be very dependent over the quantity sold. At the same time, quantity sold can be very dependent over the price. In such a way, we have here price of wheat is dependent of the quantity of the wheat produced. At the same time, the wheat produced as well will be dependent over the price of the wheat. So they will not produce wheat if the price is low. The price of the wheat is high if the quantity of the wheat produced is low. The price of the wheat is low if the quantity of the wheat produced is high, meaning there is a higher products produced. So bivariate or simple linear regression is defined as a formula of y, which is the dependent variable, and x here, functions of x, is the independent variable. So the regression model is, we have y equals beta 0 plus beta 1 times x, wherein x is your independent variable, plus e, where e is the margin of error or error. So the model has two variables, the independent or explanatory variable x, so this is your x, and the dependent variable y, the variable whose variation is to be explained. So the relationship between x and y, so this is your x, the dependent on y, is a linear or straight line relationship. So two parameters to estimate, that is the slope of the line beta 1. So this one determines your slope, and the y-intercepts beta 0. This is constant where the line crosses the vertical x. So where the line crosses, meaning what the value would it start. So E is the unexplained random or error component. So E, or the epsilon, is the error component. So much more on this. There will be another discussion for that. So linear regression model, to further explain of the model a while ago. So we have your y is the dependent variable, your beta 0 is the population of your y-intercept, your beta 1 is the population of slope, the coefficient, and your x is the independent variable, and these two, the beta 0 plus beta 1 of x, or beta 1 times x, is the linear component, while you would also put a space for the random error term, plus E of I, which is the epsilon, or should we say it as the random error component. So regression line, we have the regression model here. Again, we have y equals beta 0 plus beta 1 of x plus margin error or epsilon e. The data about x and y are obtained from a sample. From the sample of the values of x and y, estimates beta 0 of beta 0 and beta 1 of beta 1 are obtained using the least squares or another method. The resulting estimates of the model is we have here the y term as the y hat and refers to the predicted values of the dependent variable y that are associated with the values of x given the linear model. So relationships, let's define now relationships and how these relationships are interconnected, or how this has a role in linear regression. So economic theory specifies the type and structure of relationship that are to be expected. So that means economic projections of certain values, or say prices. Okay, historical data, the relationship of the data, the historical data of 5 years or 10 years. Studies conducted by other researchers, how the research of 2000 related to the research of 2001 and 2002, and so on and so forth, in terms of same domain and how they are interconnected. Different samples and related issues. Speculations about possible relationships, correlations and causations, and theoretical reasons for estimation of regression relationships. So empirical relationships need to have theoretical explanation. So uses of regression. The use of regression is that would probably depend on, or should we say that it depends on the amount of change in a dependent variable that results from changes in the independent variables, can be used to estimate elasticities, returns to investment in human capital. Then we also attempt to determine the cause of a phenomena. That means determining, or say prediction of what causes a certain looking back. So determining the different variables that cause now a certain phenomena and how they are interconnected. Prediction and forecastings of sales, economic growth, and etc. Support or negate theoretical model, and modify and improve theoretical models and explanation of phenomena. So we have here an example data of income, wherein income is the dependent variable and our hours work is the independent variable. So these are fixed value. As you can see of the data, we have here values of the hours per week, but there are also data that hours per week is longer, yet the income is lower. So, but looking at the range of the hours per week, the common range of such is from 1 to 100, and there is this value, which is the income is 1,000 and 2,000, yet the hours per week allotted is higher, which is 200 and 200 of same value, and yet generates different income. So there is what you call here inconsistencies of the generated income. So this is now a summary income as a functions of hours work, and the y-axis is the income and the x-axis is the hours per week. This is the slope is, so the constant value, or the B1 is negative 2461. So probably then this is our zero value here, and this is our negative 500. So therefore the negative 200 would fall onto this part, not at the middle, this the 0 part here, so that represent the b0 as the starting point, and our b1, beta 1 of x is our slope, so it will double the value. That would be 297. The interval will be 297 per value of your x. So this is 500, this is our value, this is the 200, this is our 0, and probably this part is the 297. Doubling it will be 500 something, so probably here, and then doubling it again would have this value. That's why the line crosses this way. Alright, so that's how the y hat works, wherein the beta 0 is the fixed value, the constant, and your 297 of function x is the interval value of your y. So for this one, the b1 here, if you're going to look at the slope or the line, that is could be of 3, and the b beta 1 is negative or going down or negative. That's why the slope is going down, or say a bit slanted down. So when you say outliers, extreme values may distort the outcome, could be an error, could be a very important observation. So outlier, more than 3 standards deviation from the mean. So here, this is an example of GPA, or say the grade point average. So depending on the time you spend online, and these are the corresponding grades point per average, and the value of your y here is negative or going down. That's why you have the slope slantly going down the slope. So the two dots here are the behaviors of a data that different from the rest, or largely shows a different value over the rest, such that if the shows abnormalities or not normal, let's say for example, if the time online spent is 4 hours, and commonly the data shows that the average GPA is on either 60 or say 65. We also have 75 and 85. Yet here the value is 10 hours and the grade is 80, and only this one shows a different value of time, a higher value of time with similar value of the GPA. Same happened with 6 of time online and the grade is 90. Wherein a common value that reaches 90 is a grade of say a time of 1, and then probably earned a grade of 92. Alright, so when you say outliers, the one that shows now different range of values among the rest. So this kind of behavior is the beta 1 is negative. That's why the slope is going down, while the value of your beta 0 is higher, and the intercept starts at 4. Okay, so another example of the correlations of 0.8. So for these, the line could probably be from having a negative 0 and 0.8. So ang line would somehow create a 0.8 line. It's either up or straight depending of your beta 0. So this is now a 0.12 correlation. So ang 0.12 correlation type of graph that creates now a U-shaped relationship. So for examples of, I think this is just 3 examples of using linear regression in real life. One is, let's say for example, you would like to determine or say compute revenue, and then how are you going to do that? So that would be beta 0 plus beta 1, and your x is the ad spending. So the coefficient beta 0 would represent total expected revenue when ad spending is 0. So revenue ito, and how much will you spend for advertisement for your revenue. Then coefficient B1 would represent the average change in total revenue when ad spending is increased by 1 unit, so $1 for example. So if B1 is negative, if your B1 is negative, so your slope will go down. So it will be like that. It will go down because it's negative. It would mean that more spending is associated with less revenue. While if B1 is close to 0, it would mean the ad spending has little effect on revenue. So when you would have B1 that is 0, the line is just straight. So there's no such significant change in terms of revenue, or there's no significant value of the revenue, changes in the revenue. If B1 is positive, it would mean more spending is associated with more revenue. So that means if the value is higher in the spending, the revenue would also increase. So depending on the value of B1, a company may decide to either decrease or increase their ad spending. Another example, blood pressure. So you would have beta 0 as your constant, and your B1 is the slope. Okay, so the dosage is your X, or your independent variable. So the coefficient of beta 0 would represent the expected blood pressure when dosage is 0. So that's just straight line. The coefficient of beta 1 would represent the average change in blood pressure when dosage is increased by 1 unit. So blood pressure will increase when dosage would also be increased. If beta 1 is negative, it would mean that an increase in dosage is associated with a decrease in blood pressure. So that means if increase in dosage, negative si beta 1, that would mean associated, the increase in dosage is associated with a decrease in blood pressure. So pambaba ang dosage, mababa din si blood pressure. So if beta 1 is close to 0, it would mean that increase in dosage is associated with no change in blood pressure if 0 is close to 0. So that means if this is close to 0, no effect on the blood pressure. But if beta 1 is positive, it would mean that an increase in dosage, increasing the dosage, is associated with increase in blood pressure as well. So that's linear. So when you increase dosage, blood pressure would also increase. Depending on the value of beta 1, researchers may decide to change the dosage given to a patient. So another one. This is an example of but this is more of a multivariate because you would have multiple variable already, but I haven't discussed yet with multivariate. So unlike with the single variate that you just only have one variable, one independent variable that determines now the dependent variable. So for example, this one, you only have dosage as your independent variable. For this example, ad spending is just one variable to determine the revenue. And for this one, this is already considered as a multivariate. So that's it. A simple example of a simple linear regression. Let's have another example.